Okay guys, welcome back. So today we'll be doing the trigonometry where we'll be proving that our right hand side is equals to the left hand side. So we're proving that this side, which is our left hand side, is equals to our right hand side, that this thing here is equals to this one. So we'll start by proving the left hand side, which is this one, is equals to this one. So the left hand side, that's what we are going to prove. So we have 2 tan x minus 2 minus sine 2x all over 2 sine squared x. So we know this one tan can change to be sine x all over cos x. We know that one, and we know which this one, it's a double angle. What is that double angle? The double angle is 2 sine x cos x. Now we have this division sign here. I've already introduced this division sign that is here because of this tan. Now what I'm going to do, I'm just going to put this division sign, this one, big one here, which is divided by this division sign, divide all this thing by what? By 2 sine squared x. I hope you understand that one. And then here we have this division sign, and all this thing, it's what? It's over 1. So what we're going to do here, we're going to take our LCD. Then what is going to be our LCD? Our LCD is going to be cos x. So cos x is going to be LCD on this side. Remember, here before the division sign. And taking the LCD, what we are going to do with the LCD, we take the LCD and times this thing here, like sine x over cos x. We times it with our LCD, which is cos x, and then cos x cancels cos x. We're left with what? Sine x. So it was 2 here, so it's going to be 2 sine x. So we're going to have 2 sine x. I hope you understand that one. And then minus taking all this thing here, which is 2 sine x cos x. We times it with our LCD, which is cos x. What you are going to get, this cos going to times this cos, so it's going to be 2 sine x and then cos squared x. So we want to have minus 2 sine x and cos squared x. And this division sign, this thing, all this thing is over 1. I'm going to change this division sign to a multiplication. Then if I change this division sign to a multiplication, what we have there in the denominator is going to be on the numerator. That one in the numerator is going to come to a denominator, so it's going to have 1 all over 2 sine squared x. I hope you understand that one. And then from here we have sine on this side, we have sine on this side, we have 2. I hope you see that there's the common factor there. So we're going to have 2 sine x as our common factor. Then if we take 2 sine x here, we're going to left with 1. Why 1? Because if you're taking 2 sine x times this one, it's going to give us this one. And then minus taking 2 sine x, you're going to left with cos squared x. So it's cos squared x, close the bracket, then all over here, denominator times the denominator, just going to give us 2 sine squared x, then cos x. I hope you understand that one. Here from our identity, we know that 1 minus cos squared x is equals to, this thing is equals to sine squared x. I hope you understand that one, you know that one. And then here we only have sine, 1 sine x, we have 2 sine x. So this 1 sine x is gonna cancel one of the sine squared x, which are 2 here, and 2 cancels 2. So you're gonna left with this thing here, which is sine squared x all over 1 sine has cancels with this one, so we're gonna left with another sine squared, not squared, sine x, and then cos x, and then we're left with 1 sine, we have 2 sine x, and then in this 2, 1 is gonna cancel one of these, and then we're gonna left with 1 sine, so it's gonna have sine x all over now cos x. Then this thing is just equals to tan x. Now we have proved that our right hand side is equals to our left hand side. Thank you so much. Okay guys, now we will look at this example, but this example now, it's not the proving, it's simplifying, where we mix our reduction and our compound angles. So this one is saying 4 cos of a negative x, then cos of 90 plus all over this sine 30 minus x cos x plus cos 30 minus x times sine x. Now from here, what we're going to do is saying 4, then cos of a negative angle, supposed to know that cos of a negative angle is positive cos x, and then times, and then cos, it's positive on quadrant number 4 and quadrant number 1, and 90 plus it's on second quadrant, so it's on a different quadrant. Now we're gonna have a negative, but since we have 90, our trig ratio here, it's gonna change to the sine x. I hope you understand that one. All over. Now this one here, what is here? I hope you see that it's sine of an angle, then cos of an angle, and another cos of the angle. Hope you see that this one is the same as this one, and then this sine here is the same as this one. So this one, it's your compound angles. Hope you still remember that one, where it's sine cos and then cos sine. Then you need to know which one is that one. So this one is a sine, the compound of a sine, where it's saying 30 minus x, which is the one angle, this one, and then since it's plus here, it's a positive 1. I hope you know your compound angle is there on your formula sheet also. So plus another angle, which is what, which is x. And then from there, what we are seeing, we're gonna times this one here, just gonna be 4 negative 4 cos, it's negative 4 cos x sine x, then all over x here gonna cancel x, so we're gonna just left with sine 30. Sine 30 is it's 1 over 2, so it's called negative 4 cos a special angle, then sine x all over 1 over 2, then negative 4 divided by 1 over 2, it's going to be negative 8 cos x, then times sine x. Then one will say, when we reach this stage, we are done with our simplification, but I don't think so. What I can do here, I would try to separate these 8, finding that it's negative 4 times 2 is gonna give us 8. Negative 4 times 2 is gonna give us 8, and then we're gonna have cos x times sine x. Now this thing here, I hope you see it, it's a double angle of what? Of sine. So we're just gonna have negative 4 sine 2x, and then from here now we can say that we are done doing what? Doing our simplification, which is our sum. Thank you so much. I hope you did understand.